Hi everyone, welcome to chapter 11. This one is on chi-square tests, and hopefully, just like the last chapter, this will be a lot of review for you. There's not a lot of new material that you will learn in this chapter that you haven't already learned in the lab. The one thing that you should remember from the lab, well, I guess a couple of things that you should remember from the lab is that this is the only non-parametric test that we are learning about in the class. But the other thing that's important to note about this particular test is that we look at frequencies. This is not a test that compares means. It's all about counts, head counts or case counts. All right. The other nice thing about this chapter is that you can now say the once forbidden word, and that word is relationships. All right, so don't feel guilty saying that word anymore. Okay, so just to start off with a little bit of a reminder, because I did mention that chi-square tests are non-parametric. So I think it's a good idea to go over what the distinction is between parametric and non-parametric. So first of all, you can probably know where I'm going to go just by this little hint over here. One is high, one is low. What am I referring to? Hopefully you remember, I'm referring to power. All right. So parametric tests are quite powerful. So that makes them very desirable, right? Because by being very powerful, it means that they have a good chance of correctly identifying treatment effects when they exist, all right? But the downside of parametric tests is that they have quite a number of assumptions, and those assumptions can sometimes be difficult to satisfy. Now, the parametric tests that we've learned about in this class include all of the t-tests and all of the ANOVAs. They're all parametric. Do you remember the assumptions that they all share? All the t-tests and all the assumptions, all the ANOVAs? They share the core, right? But then there's the plus one more in some cases. So you need to make sure that you know what assumptions make up the core. And of course, there are 3 of them. And the plus one more can either be homogeneity of variance, and that would apply for the between subjects factors, or sphericity, and that applies to a within subjects factor that has 3 or more levels. Okay, so that's the plus one more. There's actually 2 that fit that plus one more category. Okay, now for every parametric test, there is a non-parametric equivalent. So let's just say, for example, that you want to do an independent t-test. So you want to compare the means for 2 groups, and there are a completely different set of people in each group. Okay, so it's between subjects. That would be an independent t-test. Now, what if you, let's say, violate the assumption of normality? Well, SPSS does give us a modified version of that independent t-test that we can look at. But if you were going strictly by the book, you would need to run a non-parametric test. And there is a non-parametric test that is the equivalent of the independent t-test. Okay, it's the independent version of the t-test, only a non-parametric format. Now, I don't teach all the non-parametric equivalents just because we don't have time. But they are listed in your book. There's a table that shows you which test, which non-parametric test lines up with which parametric test, and you can always consult that. Okay, now, the non-parametric tests are not as powerful, but they have fewer and easier assumptions to satisfy. So although we don't like the fact that they are not as powerful, we do like that they have fewer assumptions and easier assumptions to satisfy. But I want to point out that non-parametric tests shouldn't always be considered the fallback category. You only do these tests if you absolutely have to. I don't want you to think that way, because there are situations where non-parametric tests are in fact not only your only option, but the desirable option. All right? What if, let's say, you have a dependent variable that is measured on a nominal or an ordinal scale? Well, in a case like that, you can't even run parametric tests. These are not an option for you anymore. So the desirable test would be non-parametric, okay? So again, that's when you have nominal and ordinal data. So just to summarize this, to make sure you've understood, non-parametric tests are not just tests that you run when you have violations to your parametric data, right? So sometimes, yes, they are done when you have these violations, but other times non-parametric tests are conducted because they are the correct test, right? They are the test that you would need to run. And an example is when you have nominal or ordinal data. And what's good about these non-parametric tests is that they can answer questions about relationships that the t-tests and the ANOVAs don't do. Okay, so t-tests and ANOVAs, it's all about the means. Chi-square test, well, one particular type of chi-square test, it's all about relationships.